in the industry. And for us, for UniCredit, it's very important because change the mindset to machine learning, data science, and so on, but change the mindset of the business and change the use cases. This is important because with this technology, it's not technology, it's a new branch of this application. We can extract some additional value for the bank, in my case, okay? And I think that is very, very important for the industry, and only with the research we can do it. This is important. The role of the research in this path and after the industrialization, okay? Thank you very much, and I'm very glad to stay here. And if you have any question about UniCredit, about the organization and so on, you can contact me on Ivan in a normal channel of LinkedIn. Thank you so much, and enjoy this evening. Thank you.
Thanks, Riccardo. And well, it's not yet the moment to jump on our two interesting speeches that now Riccardo has said that great words about that. We hope that you will enjoy that in the way we enjoy while developing, because before we should also present our friends of data science Milan community. Sorry, first maybe and then Paolo, if you want to say a couple of words about that.
Yeah, thank you so much. Okay, so hello everybody. So welcome to this UniCredit meetup event. So I'm Paolo Testa, I'm the data science community manager of Data Science Milan. And so just let me, okay, so for those, I see actually a lot of many new faces, newcomers to this kind of event. So for those of you who doesn't know us, we are a community, an independent group of community. We started in the late 2016. And what we do, we organize tech talk, so data science meetups in Milan, actually. So our aim, our focus actually is tech talk for data practitioners. So we would like to understand what does it mean to apply data science, machine learning, now generative AI at an enterprise level. So on real world use cases, you know, there is a lot of marketing, a lot on LinkedIn posts and so on about what is generative AI and so on. But we, as a group of practitioners, of data scientists, data engineers, would like to understand what does it mean in an enterprise or in startups. Okay, so how can we do this? We organize once a month, about once a month, 2 months, meetup, so based in Milan. And we are more than 2,000, actually. All of this is possible thanks to our staff. So you can see over there many of us. So if you want to meet us, to organize some event, please, you're very welcome to talk with us. Just another couple of information. So we have organized more than 100 events, and 70 of these are also available for the past events on our YouTube channel. Of course, even if, so our core, as you can understand, is to have meetups in presence, because we really think that networking is super important to understand actually what does it mean to apply data science in real world use cases. But we also have the real-time event in our YouTube streaming, and you can see all the past events just in the same channel. There is also the slide share, so all the slides that you can see here in our events, you're gonna find also there. And we have also our Medium blog where you're gonna find the wrap-up, the summary of our events. And how can you reach us also not in present but online with our LinkedIn channel, or we have an email that you're gonna find here. So if you want to organize an event with us, just right here, contact us with LinkedIn, or you're gonna find us here tonight. that's all. So enjoy the event, and thank you so much, UniCredit, for this.
Okay, thanks, Paolo. And also for all of the organization that took a lot of people here, despite the rain that is outside our office today. And before to ask for the next presenter to join me on stage, just a few words about how we are dealing with the Q&A session today. We are going to actually answer all of your questions all at the end of the two speeches. Then please scan the QR code now, and also if you're here, I mean, do your questions, or also if you're connected to your question, thanks to Slido, so we can proper rank and prioritize the questions for the last part of today. Then I see that most of you has already did it. Then I hope that most of you have completed the scan of the QR code, and is now the moment of the first of the two speeches that is actually with two speakers, Andrea Galliani and Lorenzo Severini. And then Andrea, the stage is yours for the first of the two speeches about the more industrialized application or next to industrialization.
Okay, Just thanks, Ivan, for the introduction, and Paolo. So just one thing, Ivan, I never tried the remote, just I need to...
The big one. The big button, yes.
This one to change, okay, thanks. So thanks for the introduction, and Lorenzo, today Lorenzo and me will talk about, we'll present an application, a project that we are developing. We're still in the developing phase within the AI and analytic products. Is about, as the title suggests already, is about an application, is an internal web application that the employees of UniCredit use as a search engine to retrieve information about different topics and domains. As also the title suggests, again, is following a common design pattern that came out recently with the merging also of the large language model, that is the pattern of the RAG, the Retrieval-Augmented Generation model. Next slide. It's not. Okay. Okay. So here a quick agenda of the point that we'll touch and we'll cover today. After a brief introduction of the business case and the project context, we will go into details of the project, of the architecture, following the natural architecture of the application. And since there is a certain amount of complexity in this application, we will try to touch the main point that we thought of interest, and giving the right amount of, let's say, engineering and data science side. So let's see where we start from. So probably, as you already know, UniCredit is a group bank, and it counts thousands of employees. Inside every branch, every country, we have a portal that is the search engine we are talking about. This is called UniContact. And this UniContact portal is used by the employees to do their everyday work life. So it's, they use this search engine to retrieve topic and information about different topic, products, processes, and internal procedure. For every country, this search engine is grounded by a knowledge base, okay? That is the source data of the search engine, and this knowledge base is a quite large knowledge base. So for example, in Italy, we count 100,000 of web page. And again, this knowledge base is very heterogeneous. So it's ranging from technology, product, business, and legal processes. There are also a certain amount of queries per day, so we count thousands of queries per day. And what happens is if the search engine fails, so it's not giving us the information that we want. So the standard procedure inside UniCredit is to open a ticket that is is an internal procedure that needs to be managed by a person at the end. So we need so it means, you see, that if the search engine doesn't work properly, we have a certain amount of people allocated and time to that particular task, so money at the end. So here the objective of the project. So we want to reformulate, to recreate this search engine. First of all, to improve the searching and retrieving and the life of employees, and also to providing also a tool, an advanced tool to smart interact with the tool. And also, of course, there is there is always a business drive that is reducing the number of opening tickets and then and so savings. So let's see the UniContact search engine as is. So the actual solution, the solution that we want to replace or improve at least. First of all, it's fully on-premise, so there is no any kind of cloud technology behind this tool. The search engine under the hood is powered by a keyword-based matcher, so there is no any kind of machine learning or AI-powered search engine. And the natural language and the chat and generative natural language is not supported. So you can see a simple example in the presentation in the bottom part of the slide of how it works. We can see if we want to search a simple keyword. So for an Italian speaker, cuffia is earphone. So if we try to put cuffia, we get a list of results, probably related. But at the time when you want to narrow down the scope of my question, the tool starts to fail. Here, a last slide before entering the details that we thought it was interesting to see the kind of profile participating at this kind of project. We don't have just the more obvious profile like data analyst, scientist, and machine learning engineering, but we also collaborate with we are facing and we work completely daily with the profile like UX and UX design, because there is a topic of adoption of a tool. Okay, so business translator that they bridge between the business requirement and the technical team, and also the function typics of a bank, so security and compliance, the function providing ensuring the security, the security of the tool, so responsible to verify the vulnerabilities and penetrability of the application. Also, the timeline, it's kind of interest to see how a project like this how much it takes in an environment like a bank. So almost 1 year, more than 1 year. We started from a business case, then we did a couple of months of a POC, and then we have an MVP release a couple of months ago, and in a couple of months we have the release of the production environment. So let's see let's go into the architecture, the details of the tool. We said at the beginning that this search engine is powered by a RAG that is a design pattern. So the definition is helping me. Is a Retrieval-Augmented Generation. Is an architecture. What it does is architecture. It augments the capabilities of a large language model by adding the information. It means that we can constrain our generative AI model to our knowledge base. Okay. So the RAG architecture, as the acronym says, is composed by a retrieval-augmented a generative part. But there is one part that is important. That is the indexing part. So we want to take our knowledge base that potentially can be in different format and written by different teams. So it can be very heterogeneous. And we want to extract information, enrich the information, standardize this information, and put it in a kind of database. Okay, that is the index. That is a kind of data structure, okay? So once we have the index, the RAG architecture is quite straightforward. So we have an user feeding the index with a query, and the search engine gives us a ranked list of documents that are passed to the LLM to give our generative answer. So let's go in a bit more detail. So here it's our architecture of the UniMate. That is the name of the search engine we are going to replace to improve. It's a bit what we can say about this architecture. It's quite similar to the previous one. It's a bit more. There are a bit more of details and logos. Let's say there are 3 kinds of players in this architecture. There are the knowledge base, the data. Okay. And we want to stress also here the knowledge base. We also put the icon of users into the knowledge base to stress the fact that the knowledge base is written by different teams in different topics. So it's a very heterogeneous knowledge base. There is no standard or a standard way to write this knowledge base. So it can be different format and different topics. So it's one of the challenge of this project. Okay. So we have also here a division of a bottom part and a lower part and an upper part. We have the flow going to the index and the flow of the retrieving part of the application. The other player are the second player is the cloud resource that are the resource that we consume. We can consume like the storage, the message queue, the database index, and so on and so forth. while the important part where we put the effort and our experimentation are the services, okay? So it's a microservice architecture where the services and the cloud resource communicate via request, HTTP request, sending request and receiving response, okay? So let's see in details what every of this step, what is each of these steps. We have a front end that is basically the UI that we open when we open the application. We have a backend API that is a kind of, it's not very interesting, honestly. It's kind of workflow, it's orchestrate the workflow, it just take a response, it store the logs and the feedback, it takes care of the logins part, and it send the query to the Q&A flow to receive answer and the response that we want to give it back to the user. The Q&A flow is the core part of the project and will be explained extensively by Lorenzo, and it contains the part of the search engine and the generative part. Then we have the lower part of the architecture that now we are going to see in details in a while. That is the phase of indexing. So it's the phase where we want to take the knowledge base and extract information, enrich the information, and put on a database index. So let's see in details each of these steps. Let's start from the front end. It's basically what we see when we open the new tool. We have after a login page, we have a home page where we can put our query, and the tool is giving us a list of documents with a small summary of the document and the generative answer on the top with the cited document. Of the bottom, we are also envisioning a feedback mechanism, so we can give a feedback on the document list and on the type of generative answer, giving also the possibility to put on the feedback the right URL expected by the user. So this feedback mechanism is quite important also mostly in the testing phase, because it's giving us a real world performance of how our tool is doing, and mostly is giving us a kind of test data set to use in a potential evaluation or optimization phase, okay? So let's see the data indexing. Now I will show you the lower part of the architecture, while Lorenzo will show you the upper part, the data indexing. We said that we can follow where we are in the architecture on the top right of the slide. So basically, we have web page that you can see an example of a web page. There is a lot of things. There is a title. There is a body. There can be screenshot or images, embedded file. So the first step is the data ingestion. Is more data engineering part, and this data ingestion is taking care of reading the web page, extracting the text and metadata like title, like title, ID, creation date or modification date, and make this unstructured data a structured data. Okay. So this structured data then is pushed on a storage, on a message queue that will be consumed by the indexing part. One important thing the ingestion service is doing is to keeping update the knowledge base, because the knowledge base can change every day actually. So we have a mechanism of pulling the update every 15 minutes and pushing on the queue the kind of update. Okay. So the next step is the indexing. So the indexing is starting from we left the ingestion, so it's reading is reading data from the message queue from the storage, and it indexes the document. In this step, what it does, the service is basically take the HTML content, process the HTML content, chunk the HTML content, because we don't want to push all the content on the index, because also the content is going to go through the OpenAI to be vectorized, and we don't want to have, we want to have a small chunk with very precise topic, okay? So it takes the chunk and the title, and are sent to LLM to be vectorized, and then there is a part of data enhancement where we ask to LLM, we send the HTML content to LLM, and to create a summary and of the entire web page, okay? So this is just one last slide before leaving the stage to Lorenzo. The indexing is not a static process where we take data and we push on the index and that's it. It's part of an end-to-end optimization. So there is a kind of hyperparameter space also in the index where we have to tune, to make all the end-to-end process optimal. So for example, there is a chunking strategy. We can choose a chunking based on a character, number of character, or we can use a recursive chunking or document-based chunking. Use it, for example, for the HTML, the paragraph, the built-in paragraph. So also the models that we use for embedding and generative model. We use TextAda and GPT 3.5, but all the landscape of model are potential model that we can use. The vector field that we want to use, the text analyzer, and also the algorithm. The algorithm, I will let Lorenzo explain the algorithm, but behind the algorithm that we use in the searching phase, there are actually parameters that need to be defined at the indexing phase, like the K of the KNN when it's doing the vector, when the searching step, let's say, is doing the vector matching. The scoring profile as well. We can define scoring profile like putting more weight on some fields than another. So that is it for the indexing part, the ingestion part. So I'll ask Lorenzo I leave the stage. Thank you. Hello, grazie.
Okay, thanks Andrea. Now let's focus on the retrieval and generation parts. So the goal of the retrieval part is to find the relevant chunks with respect to the query given by the user in order to pass those chunks to the LLM. And in order to find the relevant chunks, we implemented the hybrid search. The hybrid search is a search that is composed mainly in 4 parts: the text search, the vector search, and then both text search and vector search produce several rankings of chunks. Then we merge together all these rankings, and finally we rearrange the documents that we have found thanks to the text search and vector search according to the semantic similarity to the query given by the user. Now let's deep dive on those parts. The text search is a traditional full text search method where we segmented the query in several pieces, and we try to looking for those pieces in the knowledge bases. In particular, to score each document, we use BM25. BM25 is, let's say, an improved version of the classical TF-IDF algorithm, where basically the TF-IDF algorithm try to looking for the document and score more the terms that are relevant for each document. Then there is the vector search. In our case, we select two important fields. That is the title of the chunk, that is the title of the whole web page, and the content of the chunk. First of all, we compute the embedding of the title and the content. How we compute embedding? We compute embedding with the ADA2 model that is provided by OpenAI. And more briefly, what is the embedding? Embedding is just a vector representation of the text, and basically we pass to the embedding model the title and the content, and we have a vector. And what are the characteristics of those vectors? Usually, those vectors are close in a vector space if the meaning of the text is similar. Where close, I mean with low cosine similarity. And we also compute the query embedding, and then we run the k-nearest neighbor algorithm, actually an approximated version, in order to find what are the close titles and chunks to the query given by the user. Then, after the text search and the vector search, we have three rankings, one for the text search and two for the vector search. And then we merge together those rankings using the reciprocal ranking fusion algorithm, where basically each document is scored with the score 1 over the rank plus k, where rank is the position in the ranking in the text and the vector searches. And then so we have a final ranking. Then finally, we pass all those ordered documents to a semantic re-ranker. The semantic re-ranker is a proprietary model from Microsoft. In particular, it is used in Microsoft Bings that rearrange the documents according to a semantic similarity from the documents to the query given by the user. Okay, this is the retrieval part. That was the retrieval part. Then the output of the retrieval part are several chunks that are relevant for the query given by the user. We select the top 4 of these chunks, and we pass those chunks to LLM. In our case, we use as LLM GPT 3.5, that is an autoregressive model provided by OpenAI with a context window of 16K. And in particular, to manage all the flow, both the retrieval and the generation part, we use Microsoft Prompt Flow and the Python SDK of Microsoft Azure. In order to query the LLM, we design a prompt, where the prompt, first of all, there are the instructions. So, for example, we told to LLM that is an AI assistant for the UniMate employees. Then we pass the context, that are the relevant chunks that is the output of the retrieval part, and the input question. And then we ask to LLM to produce an answer with the citation to the relevant chunks. We are in a bank, so safety and security is very important. So in order to limit and block the harmful content, to limit the misuse of the system, and most important, to limit the hallucination, where the hallucination in the context of LLMs is the generation of, let's say, nonsensical or incoherent answer, we implement guardrails, basically that are mechanisms to block and to control the output of an LLM. In our case, we implement 3 main guardrails. One is the topical factual consistency rail, where we implement, using the Rouge score, a guardrail that checks the similarity between the generated answer and the context, and if those similarity is below a certain threshold, we block the answer. We also implement a citation guardrail, because if the answer has no citation, there is probably is not related to the question of the user, or is out of the context of banking context. And we also, thanks to the prompt, we also blocked all the questions that are not in the, let's say, in the banking context. In order to test the performance of the guardrail, we implement a red teaming dataset that, thanks to the business, we collect a series of adversarial questions that should be blocked by LLM. Okay, I spoke about the implementation. Now let's focus on how we evaluate the performance of our system. First of all, we evaluate the performance in 2 different ways. One, with data sets that are provided by us by the business, another with the user feedbacks, because we had a few hundreds of employees that test the tool and gave us some feedbacks. The datasets that we use are one with question and answer in natural language generated by the business, another with keywords and answer generated by the business. We are interested in keyword queries because the way to query the whole search engine, UniContact, was by query, let's say. Then we also have query and answer generated by the LLM, but validated by the business. We have the red teaming dataset, and we also collect from the feedback, from the previous version of the feedbacks, an hallucination dataset that we evaluated using the tool that I'm going to show you. And for the feedbacks, we collect the feedbacks from the employee, and we ask the employee several things, if the answers were okay, if the document retrieved were coherent with the query, and we also ask for a final grade between 1 and 6. Okay, what are the performance? For the first of all, the users say that the user experience with respect to the whole search engine, UniContact, was improved a lot. Then, more in detail, we measure the performance in two different ways, the retrieval metrics and the generation metrics. For the retrieval metrics, we use several information retrieval metrics. For example, the precision at 1, that measure if you are able to find the relevant web page in the first position in the ranking of the documents, and the hit ratio at 4, that measure if you are able to pass to the LLM at least one coherent document. And we also measure those metrics, and we compare the performance with the whole search engine, UniContact, and we see that with respect to the keywords, our performance are comparable to the old UniContact, but with respect to natural language queries, we outperform UniContact. The generated part were evaluated with several ways. First of all, we count the number of questions blocked by guardrails, and also the number of questions that could be potentially answered, but that were blocked by guardrails. For this, we use the hit rate at 4 in the blocked answers. And then we also implement a metric that is called groundness, that using the LLM, assess if the answer is coherent with the provided context. Okay, and that's all. Let me conclude, and that me and Andrea presented, let's say, a full delivery journey of a Retrieval-Augmented Generation search engine in a bank. As you can imagine, a careful design of the both architecture and data science part is crucial in order to have a product that improves the user experience of the users, in particular, UniCredit employee. Of course, this is an ongoing project, so we have a lot of future improvement. In particular, we would like to include other knowledge bases, perimeters, and more challenging more languages. We would like to also to evaluate the performance with other LLMs, and we would like also to try to handle more complex queries, so implement a chatbot. And finally, since we would like to improve the safety of the model, we think to design more advanced guardrails and also use off-the-shelf frameworks for handle guardrails. And that's all. Thank you.
Okay, thanks Lorenzo and Andrea for this interesting speech about this project next to its final phase and to be used by our colleagues. Once again, scan the QR code for the Slido part of the Q&A session. There is already plenty questions on the platforms, and remember also to vote the questions, since there will be probably not the time for to answer all of them. Then we will go to prioritize the more voted one. And now is the moment to also the second speech of today that is more related about a creative usage of large language models. Then large language model not applied to language, actually. Then Davide, the big one.
So, hi everyone. Thank you for being here. And as you can see from the title, we will talk a little bit about reinforcement learning and a little bit about LLM. The agenda will be start talking about the business case. Then we will move on understanding how to insert the business case inside the workflow, and we will reach a problem. And we will see if LLM can help solving our problems, and we will end with some challenges. So, the business case. we are talking about the ATM. Okay, UniCredit has thousands of ATM in Italy. And in order to guarantee the operativity, ATM should always have money. Should always have, but not too much, because it can be risky. So we have to optimize this part. Our idea, that is the objective of this POC, is to create an agent trained with a reinforcement learning approach that should be able to maximize the ATM operativity. But what we want to maximize? We want to optimize the amount of money present in every ATM. But furthermore, we also to optimize the number of travel that are weekly performed, because you can imagine if I perform a travel every day, the ATM will always have money and everyone will be happy. The problem is that this is costly and also risky. So we have decided to tackle the problem using a reinforcement learning approach that is a little bit different respect to the classic supervised learning, where you have to train a model starting from a data set of trained example. Here, the approach is different. We have an agent, okay, that actually is based on the state. He will decide which action to take inside the environment, okay? The environment, based on the action, he will land in a new state and he will output a reward. The reward is a sort of measure of how good or bad was the action that the agent decided to take, okay? And based on this information will be fed again inside the agent, and the agent, based on the reward, will understand if the action that he took previously was bad or good. And based on the state, he will decide the action to take in the next time step. You can think about this like a natural way of learning. Just imagine a child that is in an empty room, he see an electric socket and put the finger inside the socket. He will get electrified, he will land in a bad status, and probably he will not execute that action again, okay? But now, how can we insert our business case inside this workflow? This is how we do. So the agent will be a neural network, okay? Is what we have to train. The action will be the amount of money that we have to put inside the ATM. That can be 0 if that day we don't want to put anything, or whatever it is till a maximum that we can define. The environment is, in theory, is everything that is outside the agent. In practice, we have to restrict it to our case because we cannot model everything. So it will be the set of ATM with people interacting with it. The state, we have decided to model with few variables, like the date, like the stock, the withdrawal amount. Okay. The reward, instead, has to be modeled based on what we want to optimize. At the beginning, I said that we want to optimize the amount of cash, so presence in the ATM. So we need to give to the agent a negative feedback if the ATM are empty. Furthermore, we have also to give to the agent a negative feedback if we are asking too many travel. Okay, but here you can see a little problem. I don't know if one of you saw it. Just imagine here you have an agent is put in production with some randomly initialized weight. He will start trying random action. And this is not feasible. We cannot train an agent directly in production because he can also never decide to fill the ATM, and we will have the ATM empty for every day. So, and he will need some time in order to understand that what he's doing is wrong. Okay, but that period will be a cost for us. Okay, so we've decided to model the problem from an offline approach. What we mean with offline reinforcement learning? Offline reinforcement learning means that we have an agent that has to learn near optimal policy from a dataset of collected data. So we have our dataset, and starting from our dataset, we model a model of the environment. Okay, this model of the environment will become a sort of simulator. Okay, so instead the agent, instead of interacting directly with the environment, will have to interact with this model. But what this model does have to model? Okay. As I said, the variables that we have in our status for the moment are not a lot. The date is just the date we have. The weekly number of travels can be calculated because we have said, as we said, the agent actually decides if he wants to fill the ATM. So it's something that can be calculated based on the agent. The current stock can be calculated with a simple subtraction between the stock at the time before minus the amount of withdrawal. What we are missing is this, the withdrawal amount. Withdrawal amount depends on the customer that are interacting with the environment. So we have to model this. And how can we have this? So we have decided to tackle the problem as a forecasting problem. Basically, we have to, our model of the environment will have to, given a sequence in input, predict the amount of the current day. Okay? And here comes our idea. But can LLM help on solving this forecasting problem? Yeah. Why are we thinking like this? If you think a large language model, in simple words, has to predict the next words. Okay? A forecasting model has to predict the next values. Both the model has to model the sequential structure of data in order to being able to predict future patterns. So has this kind of similarity. But how, what is that is letting these large language models able to work with this sequence of data? The core part of an LLM is the attention module. Okay. The attention module can be seen as a matrix that is able to identify the affinities between tokens. Okay. So actually, he's saying how much of the past is important for the current token. In this example that I generated using a simple little LLM, Gemma 2 billion, I give in as input that string that you can recognize is a part of the Fibonacci series without anything else, so I give him no context, nothing else. On the image in the center, you can see some colored part. That is the representation of the attention layer of the model. Okay. As you can see, there are various layers, various heads. Basically, every head is trying to model a different behavior. It's trying to find different patterns. Okay, there is the head that will search for affinities between consonants inside the time series, and there is the head that I found that actually understands something interesting. If you move a little bit on the right with attention, is a joke, but I mean the same. You will see two columns. Okay, on the left columns, you see that with the mouse I'm hovering the token. On the right part, instead, you will see some colored square, okay, rectangle, and the right part is indicating how much the important token that are important for the token that I'm hovering. So actually, the model, without any context, is kind of understanding that the current token basically depends from the previous two tokens. So this is exactly what we wanted, and if you think. And yeah, there are further motivation that has give us the idea to continue towards this direction. So the generalizability, okay, that this large language model has demonstrated a high capability of few-shot and zero-shot transfer learning. Yeah. There are various papers that are showing this. We tried. They are working, not as good as we want, but are working. But this means that with few data, you can be able to train a different model that is giving you good performance respect to the classical forecasting approach that you need tons of data, and they will work and they will remain basically strictly related to the domain of data that you have used. Instead, here, with few data, you can swap the domain of the model, okay? The reasoning. This model has demonstrated sophisticated capabilities of pattern recognition. In contrary, the classic approach are more statistical, okay? And the final is that, yeah, this can be easily optimized because you don't need to full retrain an LLM in order to obtain this behavior. The retrain is really little. Okay. This is the architecture we have built. the input part will be our time series. We will, the time series will go towards the first layer that we have called Patchify. That is not only one layer, is a set of operation and layer that actually are performing a patchification of the input. So basically they merge close time step of the series, merging that in a patch. This will help the model on better finding the local patterns of the time series. And also we are reducing the amount of input that we are putting inside the transformer, because the transformer has a problem that the memory consumption is quadratic on the length of the input. And with this, we are actually reducing the input. After this, we are going towards a linear layer that will simply have to transform the time series in the dimension that the model is expecting. Then we put our large language model comes. We have decided to do a little fine-tuning using a low-rank adaptation approach. So basically, the weight of the model will remain totally frozen, so will be untouched. And we will train two low-rank adaptation matrices. And the input will equally pass through both the side. And at the end, there will be a coordinate-wise sum, okay? The idea behind LoRa is basically that these large language models has a lot of hidden behavior, hidden feature, okay, that with this approach can be emphasized. So and what we are doing, we are actually emphasizing these large language models on working with time series and recognize these patterns, okay? After this, we are going towards a linear layer that will simply have to transform the output of the model inside the final result. These are some results we have obtained. We have tried various approaches. The one you can see here are mainly transformer-based, because we saw that a lot of state-of-the-art approaches that are arising are all leveraging about the transformer power, and a lot of also on using these large language models. For example, there is here one that is called FPT, that is fully pre-trained transformer, that also here are using an approach with the LLM, in particular using a little model, a GPT-2. And they are fine-tuning it, totally freezing the attention module, and fine-tuning only the layer norm and the embedding. This paper is really interesting because are talking about the fact that this attention layer of these large language models are kind of learning some data-independent capabilities. And so going to touch the weight of this attention layer, you risk to break this property, okay? So also LoRa is not an invasive model to fine-tune. So the fact to don't go towards a full optimization is not only for a problem of don't having enough computational resource, but also for this motivation. By the way, coming back to us, you can see our model. The results are very comparable. In general, our model is behaving better. I just printed out here the value of 3 different time series of our dataset of daily transaction. And the plus of our model is that is following more the real time series. The other module are more going towards generating a mean of the values, so are more smooth respect to what we find out. And yeah, that's it. So challenges and next step. So as you can understand, this is a little research topic that we are trying to build inside our team. So the first step is that, as I said, now we are using one model for ATM. Our goal is to use one model to build, I think say for all ATM is a little bit too much, because I don't think it's feasible, but at least to cluster by behavior and use less model, okay? The second part is the fact that we have to integrate this system inside our reinforcement learning workflow. we have already started working at this. We have some first results, but we still have to work on this. And at the end, because we would like to generate something that will have to be put in production, we have to create a reliable system. And for this, we have to focus on safe reinforcement learning techniques.
Thanks, Davide. Stay. Thanks, Davide, for this presentation. Actually, very interesting. And I want to mention that he actually reconstructed all of the animation of the slides. It is crazy for me because some of those was very complex. But well, we are now on the last part of today's event, the Q&A part. Then I will ask to all of the speakers of today to join me on the stage and I see that we have quite a lot of questions, and I will see who was the question for. Maybe the first one is actually for me. Does UniCredit have a global multi-country data science community? If yes, how big is it, and do you have any regional insights? Well, actually, yes, we do have a data science community that we kicked off in 2018. And at that time that we collect all of the names, we had something like 600, 700, 800 of people, not everybody data scientists for sure, but among data scientists and people who wanted to know more about data science. Now, we do not have a more recent number of people interested, or people of data science community of UniCredit, since now this initiative was converged into the other initiative we do at digital level on topics such as the meetup that we are here today. But yes, maybe we are gonna having some further insight of this in the future. Then, if these questions come from an internal colleagues, please reach out to me. And if also is external, please use LinkedIn for knowing more about that. Then we have a second question more related to the speeches, that what type of data can be processed on the ingestion pipeline, PDF, Word document? Maybe this is for...
I take this one. It's, well, all type of document. So the document, basically the data are on the SharePoint that is a Microsoft product, and this, it's a kind of database, let's say. And this product exposes an API where we can call to get the data. So we retrieve data. The HTML content we retrieve as a JSON format, but all the embedded file, we can treat all the embedded files, so PDF, Word document, PPT, XLS, and so on and so forth, and make it pass into the ingestion pipeline. We didn't yet envision the indexing part for that document, so we just index in the HTML content, but we do have on the ingestion pipeline. I think also the second I can take. So the data, okay, first of all, the data of UniContact, it's low confidential, let's say, so it's not...
sorry, maybe for we read the question, because...
as far as you are working on with OpenAI, is there any phase of process where you encrypt sensitive data before to send information to ChatGPT? We do have a phase of encryption with a customer key encryption, so a CMAC phase where we encrypt data, so the data after the ingestion pipeline, we encrypt and we index with this key that at a searching phase then needs to be, let's say, decrypted. Okay.
Yeah, but consider also that we are not using OpenAI, the open one that
yeah, we use the OpenAI.
Exactly, the sense data.
The OpenAI, yes, of course. All the project has been built on Microsoft Azure, so we are using the managed OpenAI instance on Azure.
And then in this case, I don't think that we have sensitive data, actually.
Yeah, indeed. I was saying at the beginning, the UniContact data is classified as low confidential, I guess. Okay. Not sure of
exactly.
the... Yeah.
So there's no risk in this case, but consider that each application has a specific assessment on these kind of topics. Then we are quite safe about that. Then we have, I would like to know how you decided to handle cost of generative AI. Have you set any consumption limits? And well, I mean, consider
that's a difficult one.
there's
A question to
there's a difficult
to a person
one
on the
now.
audience,
Yes.
but yeah, I think we are.
Consider that all of these applications are at the moment in the development phase, but then of course we have we manage this the cost part in I mean in an efficient way. But I mean I will say that this is over other than the
Also,
topics of today.
just want to add one thing on the production environment. We have an instance of OpenAI that is not a pay-as-you-go. So we have a cap. We pay like a fixed amount monthly for that instance, okay, and then we can query as much as we want. So that's already a cap that we put on the production environment.
Then, do you think that creating a standard for writing future documents will be useful in terms of accuracy improvement given the cost? Are you planning to do this?
I can take it. Yeah. Okay. Yes. Actually, we are after this phase. Probably we are planning to write some guidelines in order to have, let's say, well-formed pages, in order to probably increase the performance. Of course, you don't know if the performance will increase if you don't test it. I mean, we have to test. But for example, a guideline we can add a guideline like if there are images, picture, you should also add the description, text description of those images in order to understand better what is the content of those pictures, for example.
Well, we have then questions that I don't know if we are ready to answer now because that's outperform how much NPS rates on ticket follow-ups. Then the point is that NPS, Net Promoter Score, actually is an index that is, I mean, it requires some time to be actually collected by the usage. And maybe about this, we have some tests, I guess, now.
Yeah, actually, if I have understood correctly the question is if UniMate outperforms UniContact, but by how much? I mean, how much we measure it in terms of the dataset that I showed you before. So we gave the same dataset to both UniContact and UniMate, which I cannot disclose the numbers, but we verified that, I mean, some questions, especially the natural language question, were completely not handled by the old search engine. So results were not provided. In our case, we have results in terms of retrieval documents and generated answer.
Thanks. And I guess that now we have also a question for Davide. Did you try using traditional forecasting methods?
Yes, I did. By the way, these transformer-based approach are working far better, even because we don't really have to do only forecasting. We have to use it as a simulator. So we did something that is not only following the statistical pattern, but that can do also something a little bit unexpected to train our model.
Okay, thanks. Then we have another question about UniMate. In UniMate implementation, how many people were involved across the different phases and in what roles?
A lot. I mean, a lot. As I show in the slide, there was different profiles that were working like also, let's say, under the hood, not directly, but yes. And also the industrialization phase started in October, I guess. We had a collaboration with Microsoft that started in October and ended like a couple of months ago, where I would say, I don't know, 15 persons, 15 profiles among data scientists and software engineering joined the project. So I don't know, just to give a number, I would say 20, 25 yes. Directly. Then, of course, there are a lot of persons behind that works a lot as well.
Okay, then how is the security in the international knowledge base handled in relation to the connection with OpenAI? I guess that this is already answered before. Then do you index your ticket system?
Do you index your ticket system? We have in the index we provide. Okay, if I understand correctly, I hope so.
Yes, there's
if
many
the index we have the directly. We have directly the URL to open directly to the page that we list on the ranked document. So we have the URL to, if you want to open a ticket anyway because you are not happy with the answer, that URL is already pre-filled to bring you on the pre-filled ticket that you want to open. So if this is the question.
Yeah.
Far,
no, the next one we already answered. Okay. Then actually, it was written into the slides, but which version of GPT do we use?
We use GPT 3.5 Turbo, actually.
And also is linked, there's also another one about this. Then how does UniMate perform over different languages?
Actually, the knowledge base is in Italian, so we test the performance on the Italian. So the only thing that we have in different languages is that you can provide the answer also in another language that is different from Italian, and then it will answer the question, but analyzing the Italian knowledge base. Adding knowledge bases from other languages, it's a next step. I mean, it's a future work that we are planning to do.
We have then plenty similar questions, actually. How you evaluate the results of that you receive using classical information retrieval techniques, or you use something else?
Well, in the retrieval part, yes, I told you we use the metrics that the classical information retrieval, like precision, recall, MRR, hit ratio, and yes. Then for the generation part, as I told you, we use different metrics related to guardrail and related to the coherence of the answer with respect to the context.
Thanks. Then we have, is the index a vector database containing the embedding provided by the large language model, or more a traditional TF-ADF-like index?
Yes, it contains also the embeddings. The embedding, in particular, it contains the embeddings of the content of the chunk and the embedding of the title of the web page.
So we then have one question for Davide. Davide, why do you predict the amount instead of using the withdrawal history for each ATM machine?
It's more a decision, because you can do both. You can work on model-based offline reinforcement learning, where you are doing exactly what we are doing, or you can go towards model-free approaches, where instead of building the model, you are using the historical data to train your agent. It's just a decision.
Okay, thanks. Then another one that I don't know if you already have a question, an answer for this. Did you plan for a way to manage frequently answered question?
We kind of envision a kind of, let's say, also to reduce the cost of OpenAI, to reduce the cost of call of request of OpenAI. We envision, but we didn't implement and actually think about too much yet, a layer of caching. So when we want to take the question, having a kind of frequently asked question vector, let's say, to clusterize all the questions similar to that vector and to put in a cache database.
Okay, thanks. And then the next one actually asks if the knowledge base is updated periodically. That is yes. If so, how often do you index it again? Consider that the project is not yet in production. Then I don't know if you already had an hypothesis about that.
Well, it's, we show in the slide that the indexing, the ingestion services was pulling the updates every 15 minutes. But it's a parameter that we can change. It's just set on estimation that we have a kind of more or less 200, 300 web page changed every day. So we just put 15 minutes because it was a kind of estimation, but we can, lower if needed.
Okay, thanks. Then why do we end up with two rankings from the vector search and one from the text search in the RAG system?
Yes, because in the vector search we have two vector fields. One is the title and one is the chunk. So we have we compute the embedding of the title, we have the embedding of the query, then we compute k-nearest neighbor, and we find what are the most close vector of the title with respect to the query, and then we have the ranking of the most close, the closer vector with respect title and query. Then we repeat the same computation for the content. So we have one ranking for the closest title, one ranking for the closest chunk contents. So we have two rankings, and only one, of course, for the text search, because we have the query, and then we do the classical full text search for each terms of the query on the whole knowledge base.
Thanks. Then, how do you tackle the problem of answering questions which are out of the scope?
Well, we handle it with the prompt and the guardrail. With the prompt, of course, in the prompt we wrote the extraction, and then questions that are out of scope some questions are blocked by the prompt. And in other part, we have the guardrails that say that if the questions are totally out of scope, first of all, sometimes there are no citations, so we block the answer with no citation. And sometimes maybe there are some citations that could be hallucinated, but then we have the guardrail based on the Rouge score that measure the similarity between the answer and the context. So if the question is totally out of scope, it's very likely that there are no the similarity score between the document in the context and the answer is very low. So we block those questions, and also the answers.
Okay, thanks. Then we have some redundant questions maybe. Then have you tried to compare reinforcement learning plus generative AI approach with more traditional time series forecasting techniques? Maybe you already answered before.
Yes, because we have to separate RL part and the generative AI part for the moment. The generative AI part, we have used it for time series forecasting. And as I said, yes, we tried also classic approach of time series forecasting, but are not working as well as the generative AI are working right now.
Okay, thanks. Then about the security already answered. Then UniMate able to understand that there is no answer for the topic.
I already answered.
Yes, that's also about the guardrail and everything. Then that were the most tricky challenge. What are the most tricky challenge to tackle? I guess that this is a question actually for all of you, and for both one application and the other one.
I start, maybe we can add something.
Yes.
I think it was a mixture of different type of challenge. First of all, I mean, trying to develop an end-to-end application. So from end-to-end, meaning with all the pieces, a web application. It was the first time, at least for me, or I think also for Lorenzo. Also, there is a technological challenge, because also working with completely on the cloud, on a cloud that we didn't know. So far, it was a challenge, and also different kind of challenge, like also more on the work, the daily work, like the agile way of working that we discovered thanks to the Microsoft team was I would say a challenge also personally. I don't know if Lorenzo agrees, but yeah, this kind of challenge.
Yeah, and another challenge was, of course, to work with generative AI. That is, let's say, an hot topic, but it's also very recent. So there were a phase that you have to, maybe something that you want to implement is very new, or it's not already discovered. So you have to, let's say, to ping pong between state-of-the-art research and delivery in the industrial setting. So it was a fun, let's say, it was a fun journey and very challenging, let's say.
And for you, Davide?
As of now, we're focused mainly on the forecasting part, so the simulator building. And just that part was a challenge because, as I said before, we tried various approaches, and none of them was actually able to model in the correct way the time series, even because we don't have to predict just the next timestamp, but we have to go towards the time, 1 day, 2 day, 365, so 1 year. So this was the most challenging part, to find a model able to long-time series dependencies. And what are the most, I think everything I will have to do from now onwards will be challenges, because it's something, first of all, we will have to find the right RL approach to build, in order to let this agent learn the best action. We will have to implement some safety policy in order to being able to put this model in production, because as I said, the limit of reinforcement learning, it has to, if you want to really evaluate it, you have to try it. And if we want to try it, we need to build a secure system. And yeah, that will be a big challenge, I guess.
Okay, then actually we have the next question is, where can I buy a shirt such as the one that the first speaker was wearing?
I can sell mine because I just bought for the presentation, so we can have a deal.
Then we can accept maybe offers afterwards. And I would say that, I don't know, Davide, if you want to, if you already have in mind something about how do you expect to train multiple ATMs operating on different contexts at the time? You already have some ideas about that, or?
Yes, I have. In my mind, I have, but I don't know if it is working. I mean, I have to try. No, I'm joking. In general, to have this result, I used a really simple model, really little, a GPT-2 with 768 parameters, so it's really a little model. And we can for sure move towards bigger model, not too much because it could be computationally expensive, but some, I don't know, also Llama 3 with 8 billion parameters, something like this, and adding to the model the information about the ATM, like the location, like the address, in order to let the ATM, the model, understand where we are talking about one ATM or about one other.
Okay, thanks. Actually, this seems quite challenging. Maybe in one of the next events we will see if this has worked or not. And well, actually, the times we also, I mean, we're a little bit over the time that we also initially scheduled for the closing of these events. Then thanks again to the speakers. And to all of you that decided to stay with us into this late afternoon or evening today. And for the ones that are here in presence, we have a networking event out of this room. And for the others, see you at the next events.